Okay, for homework 130, a big one, getting you ready for next week's Module 5 exam where you're solving all these, and then we're going to add system of inequalities to it. For tonight's homework, I'd like you to write down every problem I do, and then write down the words to show me that you are truly listening. So here we go. These first ones here. Solving by graphing, taking these two and rearranging them for y and then plotting them. So x plus y equals 3. Take away 1x on both sides, minus 1x minus 1x. Puppy, puppy. Gives me y equals negative x plus 3. That would be a y-intercept of positive 3. And then that rate of change, that negative 1 made into a fraction, negative 1 over 1, over 1, down 1, over 1, down 1, over 1, down 1. That gives me that blue line graphed. Be able to go both ways, left one, up one, left one, up one. Draw your line best you can, hopefully using a straight edge if your line is kind of wavy. The equation in red, to solve that, take that 2x minus y equals 6. Going to take away 2x on both sides. Bring down that negative y equal negative 2x plus 6. Divide everything by negative 1. And that gives me y equals positive 2x minus 6. So when I graph that, that's going to be at negative 6 on the y-axis. And then that rate of change, that 2 over 1, over 1, up 2, over 1, up 2. And then when I graph that, I could clearly see that those intersect at the point 3 for x, 0 for y. So again, solving by graphing, that is a one solution answer. That's how it looks right here on a graph, two lines intersecting. That's how it looks plain old equations, different slopes, guaranteed one solution. All right, I also want you to be able to get that answer using these two other methods. So elimination, just adding straight down, 3x, y's cancel, 3 plus 9, 6. Or it gives me 9. Divide by 3 gives me x equals 3, the same answer as this. And now to finish, take that 3, plug it into x into either of the equations. I'm taking that top one. So that top one where that x used to be, I replace it with 3 plus y equals 3. And then solving that algebraically, minus 3 minus 3, I could see that y equals 0, the same answer that my graph gave me. Same answer, but elimination method, adding straight down, eliminating one of your variables. All right, substitution. Yellow, yellow. Okay, substitution, take that. Take one equation, solve it for one of the variables, either x or y. I'm solving this for y. That y tells me where I'm substituting into the other equation. I'm substituting right here into the red equation's y. So when I rewrite that, I will have 2x and that minus still there, but in parentheses where that y used to be, I replace that with this negative x plus 3 equal to 6, and you can see where that minus y used to be, I put that negative x plus 3. You will need to distribute that negative, which gives you 2x plus x minus 3 equals 6. Combine your like terms right there to get 3x minus 3 equals 6. Add that 3, and that gives you 3x equals 9. Divide that by 3, and that will give you x equals 3, same as the other two answers. Take that 3, plug it into any of these x spots. I'm going to take this one right here because it's all set up easy for y. So y equals negative, and then put a 3 there where that x used to be, plus 3, and you can see that gives you the y equals 0 answer. All right, for my honors kids, I'm going to shrink this down and have you do it by what's called row elimination method. My regular Math 1 students, you do not need to copy this method. You know you're smart enough to do it, so it's up to you if you want to, but this is for math honors only. They're doing it a 4th way. All right, so they're taking and writing just the coefficient numbers. That 1, that 1, that 3, that 2, that -1, that 6. And what you're trying to do is to get 1s in this diagonal and 0s in this, and I'll show you why. So what I'm doing here, I'm taking all the numbers of row 1 and timesing them by -1. That's what this is showing. So -1 times row 1 plus all the numbers in row 2, and when I do that math in my head, I'm putting those answers back into the row 2 spot. So here I go. The top row remains unchanged, but this bottom row, -1 times 1, oh, that's not going to work, so this got to be -2. There we go, because that -2 times this gives me -2, plus that 2 gives me 0. -2 times 1 is -2, minus 1 is -3. -2 times 3 is -6. -6 plus that 6 will give me a 0 right there. So -2 times row 1, -2, plus row 2, 0. Put that number right there. -2 times 1, -2, minus 1, -3. Put that number right there. My next step is to get it so I have 1s in this diagonal. I need to multiply this number by -1/3, which will turn that into a +1. That's the same as dividing by -3. So taking that bottom row by -1/3 gives me the top row unchanged, 1, 1, 3. Bottom row becomes 0, 1, 0. Here's my y equals 0 answer. I'm going to take the bottom row by -1, add that to the numbers of row 1, and put those answers back into row 1. So 0 times -1 is 0, plus 1 stays 1. -1 times 1 is -1 plus this one, 0. -1 times 0 plus 3, 3. These first ones are your x column. The second numbers are your y column. The third column are your answers. X equals 3, y equals 0. When y is 0, x equals 3. When x is 0, y equals 0. So a third way, actually a fourth way. Okay, these, I want you to see what happens for these special cases. So a graphing one, taking x plus y equals 3, horse, horse. Take away x on both sides, gives me y equals -x plus 3. Start at 3, over 1, down 1, over 1, down 1. Draw that line through them. When I graph the other one in red, -x minus y equals -3. When I solve that for y, add x gives me -y equals x minus 3. Make sure all classes are writing these now. Divide by -1 gives me the red equation, which is y equals -x or -1x plus 3. And you can see that these are overlapping the same line. The red line is going through all the same points as that blue line. So that is your many solution look. Infinite solutions, same line, overlapping line. All right, the look when you do elimination for infinite solutions. When I add it, the x's cancel, the y's cancel, the numbers cancel, gives me 0 equals 0. That is a true statement, proves many solutions or infinite solutions. Proves it's going to be a overlapping pair of lines. All right, substituting a little harder. Take this and solve this for y again, minus x. Gives me y equals negative x plus 3. I'm going to substitute this into the red equation's y. So that one will give me negative x. The minus is still there, but where that y is, I replace that with negative x plus 3 equal to negative 3. I will distribute this negative, which gives me negative x plus x minus 3 equal negative 3. These x's cancel, and again, there's your true statement. Look, negative 3 equal negative 3. That's your many solution or infinite solution look. That's true. Many solutions. That's how it looks when you're doing substituting. All right, now, Math 1 students, take a little break. I'm going to show the honors kids how you get this infinite look for row reduction method. So I'm taking this equation, 1, 1, 3, negative 1, negative 1, 3. I'm going to times this top row, not by negative 1. That's not going to work. Nope. I'm going to times the top row by 1 and add it to row 2 and put those numbers back into row 2. So 1 plus negative 1 is 0. Put that answer right here. 1 minus 1 is 0. Put that right here. 3 minus 3 is 0. Put that right there. When you get that look where you have zeros all the way across a row, there's really nothing you could do at this point to change anything. That's your many solutions look when you're doing this row reduction. Zeros straight across. That's 0 equals 0 technically right there. That's your true statement. When x is 0 and y is 0, the answer is 0. All right, back to all students writing. These are the no solution looks. So this top one here, take away x on both sides, give me y equals negative x plus 3. Go up to 3 on your x-axis, over 1, down 1, over 1, down 1. Draw your line through them. My red one, when I solve that, surf. Gives me negative x minus y equals 6. Add x to both sides. That brings down negative y equals x plus 6. Divide everything by negative 1. And you'll see that you get equations with the same negative 1 slope, but one has a y-intercept of 3, the other one has a y-intercept of negative 6. So this one will start at negative 6 on the y-axis. And then for every time I go over 1, I go down 1 parallel to this blue line, but different y-intercepts. Same over 1, down 1, same slope over 1, down 1, but different y-intercepts. No solution. Parallel lines. All right, how that will look for the elimination method. When I add straight down, you'll see that everything cancels for the x's and y's, but the numbers don't. So you get 0 equal to 9. That's your false statement look. That's a no solution look. All right, substitution. X plus y equals 3. Take away that x. Gives me y equals negative x plus 3. Take that, substitute it right into the other equation's y. That's going to be negative x minus, in parentheses, negative x plus 3 equals 6. Distribute that negative. Gives me negative x plus x minus 3 equals 6. X's cancel. and then there's your false statement. -3 is not equal to 6. That is false. Black. Black. All right, for Math 1, you are done. For Math 1 Honors, you have one last problem and one last word. So here we go. How it looks for a no solution when you're doing row reduction method. So here we go. So row reduction, I got 1, 1, 3. I got -1, -1, 6. I'm going to add the top row to the bottom row to zero out this number right here. And what happens is you'll get 1, 1, 3, but then 0, 0, and then 9 right there. That is the look you're going for right there. When you have double zeros here and here in this 9, there's really nothing you could really do to change those numbers up there. That's kind of like your false statement. When x is 0 and y is 0, it equals 9. That's not true, which is the same as this. If I added 3, be 0 equal 9. False statement. Last word is canoe. Canoe. Good luck. See you tomorrow.